You're listening to Eric's blog podcast, where blog posts become conversations between two hosts who can't stop interrupting each other.
That's mostly you.
Fair. I'm Alex. I read the post, so you don't have to.
And I'm Mia. I asked the questions you're probably thinking. Let's get into it.
So let me ask you something. How do you handle dependency updates in your projects?
Oh, I just let Dependabot do its thing. It opens PRs, I glance at them, merge if the tests pass. You use Renovate, right?
Yeah, Renovate. Similar idea, though. Anyway, Eric wrote this post called Dependency Updates That Understand Your Code, and the core argument is pretty sharp.
Okay, what's the argument?
Tools like Dependabot and Renovate, and I've used both, they see version numbers. That's it. They don't read your code. They don't know how you actually use the dependency.
I mean, they bump the version and run your tests. Isn't that enough?
Sometimes, but here's where it gets tricky. He gives this example with Newtonsoft.Json. You know it, right? The JSON serializer for .NET.
Yeah, everyone uses it.
So at some point, they changed the default max depth from no limit to 64, silently. No breaking API change. Your code still compiles. Your basic tests still pass.
But if you're deserializing deeply nested structures,
Boom, it just starts throwing exceptions in production. And your dependency tool had zero chance of catching that because it never looked at your deserialization code. That's a behavioral change. The signature didn't change. The contract changed. And those are the ones that bite you at 2 a.m.
Okay, that's a good point, but that's kind of a rare edge case, no?
Is it, though? Think about how many dependencies you have. Now think about how many dependencies those dependencies have. Transitive dependencies. You might have hundreds of packages you never explicitly chose.
Right, the dependency tree.
And here's another thing that drives Eric nuts. The who broke the build problem. You know how these tools sometimes group updates? My Renovate setup does it by default for me.
Yeah, to reduce PR noise.
Right. So it bumps 5 packages in one PR, tests fail. Now what? Which of the 5 caused it? You're back to bisecting manually.
I've been there. You end up reverting the whole thing and doing them one by one.
Exactly. So the whole post is about a different approach. He built a /dev-dependency skill. It's part of his Agentic workflow.
Wait, a skill? Like the Claude Code skills he talked about in the pair programming post?
Same system. You invoke it, and it runs a risk-stratified audit of your entire dependency tree. Not just what's outdated. It prioritizes by risk.
What do you mean by risk stratified?
It goes in a specific order. Security vulnerabilities first, then patch updates, then minor updates, then major updates, then deprecated packages. Each category gets handled differently.
So security is always the top priority?
Always. And not just bump the version and hope. The skill actually does code-level impact analysis. It looks at where you import the vulnerable package, how you use it, what the fix changes.
Okay, that's different from just seeing a red badge on GitHub.
Completely different. Because sometimes a vulnerability exists in a function you never call. The skill can tell you that. Still worth updating, but now you know the actual risk to your specific code.
Right.
Then for patch and minor updates, it does something clever. It groups packages that belong together. Like if you're using .NET Aspire, there might be 8 Aspire packages that should all be on the same version.
Oh yeah, aspire.hosting, aspire.components, all that stuff.
Exactly. Those get updated as a group because they're designed to move together. But unrelated minor updates, those get applied and verified individually.
So you always know which one broke things if something goes wrong.
That's the whole point. No more mystery PRs with 12 bumps and a red CI pipeline. Now, here's where it gets really good. Major updates. The skill treats those completely differently.
How so?
Full stop. It doesn't just bump and pray. It reads the breaking changes documentation. Then it scans your code base for patterns that are affected by those breaking changes.
Wait, it actually reads the changelog?
The changelog, the migration guide, whatever's available, and then it maps that to your code. So it can say, hey, you're using this deprecated API in 3 files. Here's what needs to change.
Yeah, I never read changelogs. I just update and see what breaks.
Most people don't. That's Eric's whole point. The tool should do that work for you. But here's the part I really liked. He gives this ESLint example.
ESLint? The JavaScript linter?
Yeah, so there was the big ESLint 8 to 9 migration, completely new config format, flat config instead of the old cascading ESLint RC files.
Oh, I remember that. It was a whole thing.
Right. So the skill looks at that update, reads the migration guide, scans the code base, and then it recommends, don't do it yet.
It tells you not to update.
because the ecosystem wasn't ready. Half the plugins hadn't migrated to the new config format. You'd update ESLint and then half your plugins would stop working.
So it's not just blindly saying update everything. It actually has judgment about when to defer.
That's the key difference. A version bumping bot can't make that call. It doesn't know that your ESLint plugin for Angular isn't compatible with ESLint 9 yet.
Yeah.
And then there's the transitive vulnerability angle. You might not even directly depend on the vulnerable package. It's 3 levels deep in your dependency tree.
Those are the worst, because you can't just bump it directly.
Right, you need to figure out which of your direct dependencies pulls it in, and whether that dependency has a version that uses the patched transitive. The skill traces that chain for you.
Okay, so let me make sure I understand the flow. You run the skill, it audits everything. Security first, then patches, minors, majors, groups-related packages, applies them one by one where it makes sense, and for big stuff, it actually reads the docs.
That's it, and there's one more piece, the learning loop.
Learning loop?
Every time you do an upgrade, the history becomes part of the workflow context. So next time you run the skill, it knows what you've already tried, what broke last time, what you deferred, and why.
So it builds up institutional knowledge about your specific project's dependency history.
Exactly. Like if you tried upgrading a package last month and rolled it back because of a specific issue, the skill remembers that. It won't suggest the same update until the underlying issue is fixed. And this ties back to Eric's whole philosophy about agentic development. The tools should understand your code base, not just the surface level stuff like file names and versions.
The actual patterns, how you use things.
Right. A human developer updating dependencies would open the changelog. Check if any breaking changes affect the code. Maybe ask a teammate, hey, are we using this feature that's being removed? The skill does exactly that process.
But faster. And it doesn't skip the changelog because it's Friday afternoon.
Yeah, it never has Friday afternoon energy. It reads every changelog every time.
So what happens with the deprecated packages? You mentioned those are the last category.
Those are treated as a separate concern because deprecated doesn't mean broken. It means you need a migration plan. The skill identifies them, finds the recommended replacement, and estimates the effort.
But it doesn't just auto-swap them.
No, that would be reckless. Replacing a deprecated package is often a real refactor. Different API surface, different behavior. You want a human deciding when to take that on.
Right. It's more like triage. Here's what's urgent. Here's what can wait. Here's what needs a plan.
That's a good way to put it. And I think that's what makes this approach click. It's not trying to automate away the thinking. It's trying to do the tedious research so you can make better decisions.
I like that framing because honestly, my current process is merge the green ones, ignore the red ones, hope for the best.
And that works until it doesn't. Until you're 3 months behind on a security patch because it was buried in a group PR that failed for an unrelated reason.
Okay, yeah, that's happened.
Eric's been pretty open about the fact that this comes from real pain. He runs .NET Aspire projects with Angular front ends. The dependency surface is huge.
Both ecosystems have pretty aggressive release cycles too.
Exactly. NuGet packages on one side, NPM packages on the other, each with their own versioning quirks. Having a skill that understands both worlds and applies the right strategy to each, that's a real time saver.
So the takeaway is basically, stop treating dependency updates as a version number problem. Treat them as a code change problem.
That's it. Because that's what they are. Every version bump is a code change. Some are trivial, some are landmines. And the only way to tell the difference is to actually look at your code.
And the skill does the looking.
The skill does the looking.
Cool. I'm going to go check my Dependabot backlog now, with slightly more anxiety than before.
You're welcome. That's it for this one. If you want the full details, check out Eric's personal blog at ericleben.com.
And if you liked this, there's more where that came from.
See you next time.
Bye.